Hello everyone, I am Shamanth, CSAT faculty at Insights IAS, and for the most awaited video, that is the CSAT discussion of 2023 paper I am taking, okay, and this is the first question. Raj has 10 pairs of red, 9 pair of white and 8 pair of black shoes. See, he is having 10 pair of red and 9 white and 8 pairs of black shoes in the box. If he randomly picks shoes one by one, see, this is the keyword, one by one without replacement. He is not picking in pairs, he is picking one by one shoes from the box to get a red pair of shoes to wear. What is the maximum number of attempts? If he has given the minimum number of attempts, then that would be the answer to, means minimum number of attempts. In the first attempt only, I will be lucky to get the red shoe, and in the second attempt only, I will get one more red shoe, so I will wear both. Okay, I will wear both, but here irrespective of left and right shoes, okay, that's also matters sometimes, but in this case he has not considered that. Maximum number, see, maximum number means whenever he is removing, okay, he is not getting that red shoes, okay. So in what are the possible ways he can remove the shoes so that he should not get red shoes, means all white shoes, let's say he is getting, all white shoes. So how many pairs? 9 pairs of white are there. 9 pairs means a pair is of 2, so totally 18 white shoes, let's say he has got, okay, not even a single red. Then he is getting a pair of a black shoe, okay, 8 pairs of black shoes there, okay, after removing 9 into 2, that is 18 white shoes, he is removing again shoes for trying of red shoes. Now he is getting, how much it is, a pair of, what is it, black, okay, 8 pair of black shoes, 8 into 2, that is nothing but 16 shoes he has removed, and none of them are here red shoes. So totally 34 attempts has been gone now, and 34 attempts he has not taken even a single red shoe. Now he has not replaced whatever the shoes which has been removed. Now by default, if he puts his hand and remove a shoe, that one shoe has to be a red one, but he cannot wear a red shoe. To wear, he needs one more, isn't it? Okay, in these 34 attempts, none of them are red shoe. In the next attempt, he has to get by default the red shoe, and again if he remove one more shoe, he has to get the red shoe. So totally 36 attempts is the maximum. Okay, if he has given the minimum, then 2. Okay, in how many ways can a batsman score 25 runs by scoring single runs? 4 and 6. Okay, only 1, 4 and 6 has to be counted, and the total score has to be 25 runs. Okay, see, this is one of the toughest question here in this one. Okay, these kind of questions should not be attempted in the exam. These are meant to be left. Let's see. Okay, let's see the approach now. Very similar kind of question, denomination question was earlier asked in 2016 or 17 somewhere. Okay, 1, 4, 6. See now, the sum of these has to be 25 runs. Let's take a combination of 6 and 1s. Okay, if I take 6s here, how many 6s I should hit so that I can make 25? So closely it is 6 into 4 plus a single, okay, isn't it? So I am taking a combination of 6 and 1, okay. How many such 1? See, 6 into 4, 24 plus 1, again 6 into 3, that is 18, and again singles, 6 into 2 and again singles, 6 into 1 and again singles, isn't it? So totally 6 into 4, 3, 2, 1. So totally 4 such combinations of 6 and 1 we can do. Okay, similarly 4s and 1s, how many 4s? Okay, I can hit 6 4s, then 5 4s, 4 4s, 3 4s, 2 4s, 1 4, and the remaining number of runs will be singles. So totally how many? 1, 2, 3, 4, 5, 6. So totally 10. This has become, again now, the combination of 6, 4 as well as 1. Okay, 6, 4 as well as 1. So how many such? I can hit 3 6s here. Okay, so totally 18 it has become, plus I can hit 1 4. Okay, 1 into 4. So 22 plus remaining 3 singles, this many. Okay, if 3 6s are there, 2 6s are also possible, 1 6 is also possible. Okay, isn't it? So totally this is 3 in number. Now, similarly, okay, 4s, I can hit 1 4, sorry, 6 fours, 5 fours. Okay. Again, now the combination of 6, 4, 1. Okay. See, you can hit 3 sixes and 2 fours, 3 sixes and 1 4. Okay. And singles. Similarly, 2 sixes you can hit, that is 12 runs. Okay. Remaining how many? You can hit 3 fours here. Okay. And singles. 2 fours also possible, 2 sixes, 2 fours, 2 sixes, 1 4 and the remaining singles are also possible, right? So, how many such? Here 4, okay, these are 4. Similarly, 1 6 also you can hit, okay, and 1 6 means 6, so totally the remaining is 19, in that you can hit 4 fours, 3 fours, 2 fours, 1 4, so totally 4 here. So, this is 4, 4, 8, 12 and 6, 18, but with all the singles also you can hit 5, okay, singles. So, how many such? Only one such possibility. So, totally the answer is 19. Okay, using 6 and 1, using 4 and 1, using 6, 4, 1 and using only 1 singles. Okay, using only 6s and only 4s is not possible. Okay, next question. There are 4 letters and 4 envelopes. Look here, 4 letters, 4 envelopes. See, let's say letters 4, 1, 2, 3, 4 and envelopes A, B, C, D. Okay, 4 letters, 4 envelope. They have to be put into the exactly the same letters, has to go to the same envelope which has this correct address. If the letters are randomly inserted, okay, I am randomly inserting, okay, taking the letter and posting it in the envelopes here. It is possible that exactly one letter goes into an incorrect envelope. Let's say rather than 1 going to A, 2 goes to A, let's say. Okay, if I put 2 to A, then 1 has to go to the other one, right? Okay, if 1 is wrong, then definitely other also has to be wrong, hence this has to be false. Okay, if 1 goes to wrong one, another has to be, which was supposed to go to this one, will go to the another envelope. Okay, hence it is wrong, common sense. There are only 6 ways in which only 2 letters can go into the correct envelopes. See, look here, A and B, okay, these 2 are going to the same address and C and D are going to the wrong address. Okay, let's see, this is one possibility. A and C and A and D similarly, okay, 3 possible cases here. Similarly, along with B, B can go with C, B can go with D, possibility, okay, along with D, okay, C and D can go to the correct address, okay, see 1, 2, 3, 4, 5, 6 possible cases. So, this is exactly correct, 6 ways. So, it is 2 only. What is the remainder when this given expression is divided by 100? See, 100 here only we can divide this one 17 times of 5, 20 times, okay, this is 24 times, this is 5 times, okay, this is exactly divisible, right? So, if this number is exactly divisible, then the whole number is exactly divisible. This number is exactly divisible means the remainder is 0. Okay, see, this is a cyclicity rule, okay, cyclicity of 2. Now, any digit which ends with an unit digit of 2, okay, have a cyclicity of 4. For example, look here, 2 power 1 is 2, 2 square is equal to 4, 2 cube is equal to 8, 2 power 4 is equal to unit digit I am writing only, okay, 6, 2 power 5 is 2. Once we get 2, same thing appears again and again. So, cyclicity is 4. Hence, okay, I am taking only the unit digit to the power of 9 into 7 into 5 into 3 is 945. Okay, which is nothing but to the power of 945. For every 4, 1 is, you are getting the same unit digits, okay, for a cyclicity of 4. Hence, when I divide this by 4, okay, remainder is 1. Remainder is 1 means 2 power 1, anything 2 power 1, the unit digit has to end with what? 2. The result is 1, 1, 1, 1. Okay. Now, sum of these 2 digits, here it has to be 1 means, here it has to be 1 means, okay, it has to be 11, hence we get a carry here 1 and this has to be 11 means this has to be 1, okay, isn't it? So, sum of C and F is equal to 11, okay, sum of C and F is equal to 11. Let us say 11 we got, 1 I put here, 1 I carry, okay. I am still again getting 1, okay, you might have thinking why not 21, okay, why it is 11? Because sum of 2 digits is equal to maximum 18. 9 plus 9, this is only possible. So 20 and above is not possible. Okay, so hence I am taking 11. So here also it is 11, right? Okay, 11 means I added the carry 1, afterwards this is becoming 11. So B and E has to be what? It's 1 minus of 11, that is 10. Okay, I am getting 1, again carry 1. Along with this one, these two includes 11 here. Okay, means the sum of A plus D is equal to what? 10 only. So this is nothing but what? A plus B plus C plus D plus E plus F is equal to this much. Okay, which is nothing but 31. See here with lot of trial and errors. Okay, I have concluded the answer. I am just giving the answer with a lot of trial and errors because I have to form a concept here. So I'll get back to you with the concept, but the number is 119. Okay, this is the required number here, a 3-digit number. The difference between the 100 place and the unit place is 8 here. Okay, just give the answer. I'll come with the concept for this question. Okay, some questions are something like this. Okay, I have done a lot of trial and error here. 3 of the 5 positive integers P, G, P, Q, this is P, Q, R, S, T are even and 2 of them are odd. Okay, not necessarily in same order. Consider the following. Now, see, odd plus odd is equal to even. Okay, for example, 5 plus 3 is equal to 8. So, odd minus odd is equal to even only. Okay, 5 minus 3 is equal to 2. Similarly, even plus even is equal to even. Okay, and even minus even is equal to even. Okay, how to get odd? In additive property, odd gets like this. Okay, odd plus even is equal to odd, or else odd minus even is equal to odd, and even minus odd is equal to odd. So one of the term, if it is odd and one term is even, then definitely you will get the odd terms here. Now here, see, look here. Let's say these 3 are even. Okay, and these 2 are odd. If you have one odd and one even, you will get even. You will get odd. One odd, one even, you will get odd. Okay. Again, this one is even. See, P plus Q. If this is even and this is odd, okay, this is odd 2 will get cancelled. So even, it's definitely always an even in this one. So irrespective of minus or plus, it is even. Okay. But in this case, see, rather if I double this one, that doesn't make any difference. If you take 2 times of that one, or as 3 times of that one, 4 times of that one, okay, it remains the same thing which is even always, definitely. Okay, hence this is wrong. So 1 only is the answer. Okay, this question, P plus C by P minus C. See, I'll take an example. See, look here, consider the following respective prime numbers P and composite number C. Okay, prime means having 2 factors or else which are divisible by itself and only one, composite numbers more than 2 factors. P plus C, for example, I will take the prime number 2, okay, 2 is the first and the smallest prime number and 1 is not a prime number there, 2, okay, I will take a composite number 6, 2 minus 6, same numbers, okay, so this is 8, this is minus 4, which is equal to minus 2, okay, even means he has not mentioned positive or negative, so even is an integer here which includes both positive or negative also, so this is true, so this is positive, sorry, this is even. Okay, minus 2, which is nothing but even, hence this is true. Okay, if 1 is true, you can eliminate 2 here, or else we will go to the next condition. 2p plus c can be odd. Okay, 2p plus c. See, I will take the 2 here, 2 and prime number is 2 on any composite number I will take 15. So, which is equal to 19. Can be odd? Yes, it is odd. Okay, 2 is also true. PC can be odd. PC can be odd. 3 into 5, which is nothing but 15. Okay, the product PC means odd. Hence, this is also 1, 2, 3. Okay, this is an easy question. Okay, here I have done a lot of trial and errors. Okay, lot of trial and errors. Let me come with the concept for this question. But as of now, the number 3-digit number ABC, when multiplied with D, the result is 37DD. Okay, whatever the digit here has to be the unit digit here. Okay, I will come with the concept for this one. As of now, see, there are possibilities of 37, the number is 3744, okay. There are possibilities which are 416 as well as 624, which is nothing but into 6, and this is into 9 and this is into 6, okay. And this number is actually Okay, here 6, here 9 it is. Hence, this can't be possibility. It's nothing but 936 into 4, which is nothing but 3744. Okay, trial and error I have done. These are the possible factors of 3744, but okay, we need 4 at the end here, which comes from 4 only. Okay, now 386 and the sum of the digits here is 9 plus 9, 18. I'll come with the concept here. I'm sensing some concept here. See, here also 18 we have 18. Let's see. I'll come with the concept for that one. Here we have 11 also. 3, 11 and 13. Yes, for any choice of values of x, y, z, the 6-digit number. See, this is the concept. When 6-digit number is formed by repeating 3 digits. For example, 1, 2, 3, 1, 2, 3. Okay, 405, 405. These kind of numbers are also always divisible by 1001. Which is a combined divisibility of 7, 11 and 13. Okay, 3 consecutive prime numbers, okay, whose combined divisibility is 1001. Okay, many such questions can be formed here. I have done a lot of these things in the class. 7, 11 and 13. 125 identical cubes are arranged in the form of a cubical block. How many cubes are surrounded by other cubes from each side? Okay, see, at that point of time, little bit tricky to understand this one. Now look here, 125 identical cubes arranged in a small cubicle. See, the cubes are arranged in this way. This is the counting of the cubes question, very similar one we have done in class. Now look here, this is a 5 into 5. In this one, 5 into 5, that is nothing but n cube, which is nothing but 5 cube, which is given as 125 cubes. Okay, hence this is 5 into 5. 125 cubes are there in this arrangement. Now, if you remove the outer portions, only the outer portions, okay, inside also there will be cubes, right? If you remove this part and this part, only left out part will be, you can see somewhere here, isn't it? At the core, inside this one, if you remove this part, if you remove this part, this part, this part, okay, and above part, only this much will be left out. And that looks something like this, isn't it? Okay. In this format, we have only 3 cube, which is nothing but 27 cubes are there. Okay, very similar kind of questions. We have done painting and removing the outer structure. Inside, how many are there? Surrounded by how many are there? On each sides, it is 27. Okay, next question. Okay, how many distinct 8-digit number? Okay, different, without repetition, that's what it means. Distinct 8-digit numbers can be found by rearranging the digits of the number. Okay, 1, 1, 2, 2, 3, 3, 4, 4. Such that odd digits occupy odd position and even digit occupy even position. For example, odd digit, okay, 1, afterwards even, again odd, even, odd. This has to be even, right? 1, 2, 1, 2. Okay, there is only 2. Then 3, 4, 3, 4. See, odd positions, odd number, even positions, even number. How many such possibilities? See, this 1 can go here, this 3 can go here, this 3 can come here. Many such numbers you can form. If you change the order of the numbers here, the number becomes a different number. Okay, now permutation question. Now we have 1, 2, 3, 4 positions. For this 4 position, we have 4 characters. How many ways we can arrange them? 4 factorial. But there is a repetition here. 2 times of 1, 2 times of 3. Hence, 2 factorial into 2 factorial to avoid the repetition. And okay, we have 4 more here positions for even. Similarly, 4 factorial and there is a repetition. 2 can go here, this 2 can come here. Okay, that looks like a same number. Hence, to avoid that repetition, 2 factorial and 2 factorial, which is nothing but 6 into 6, 36. Time and work question. Okay, easy one. A, B, C independently. A can complete a piece of work in 8 days, B in 16 days and C in 12 days. Okay, take the LCM. 48. Efficiency is 6, 4 and 3, but they are not working together every day. Okay, A alone works on Monday, B on Tuesday and C on Wednesday, A alone again. Okay, this is a alternative days and the cycle repeats. Who starts first? A, then afterwards B and afterwards C. Now 6 units A will be doing, B will be doing 4 units, C will be doing 3 units. So totally for 3 days they will be completing 13 units of work, and in this manner they have to complete 48 units of work. So the closest multiple is 3 times into 3. So after 9 days, if you look, that is 39 units completed. The 10th day, A comes and he do plus 6, it's not completed, 45 it has been. Again B comes, again 11th day, he will be adding 3 more units and it is completed on the 11th day. So, the work will be finished on Thursday. The work will be finished in 10 days. No, this is wrong. 11 days it required. And is it Thursday? Let's see. Totally 11 days it has taken. Okay, if you divide by 7, the remainder is equal to 4. If it is 7 only, it will be on the same day. If the remainder is 4, add 4 to the starting of the day. That is Monday plus 4. Okay, if it is, it's not Monday plus 4, including Monday, it's 4. If it is 7 days, started from Monday, if it is 7 days, see, Monday including Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, okay, Sunday, 7 days, and again Monday, Tuesday, Wednesday, it has to be Thursday. So, 11th day will be Thursday. Hence, this is right, 1 only. So, reminder, you add the remainder to the, see, Monday to Sunday becomes 7 days, again starting Monday, Tuesday, Wednesday, Thursday. This is the 4 days, Thursday. See, look here, this is the sum of the digits here, 7. This is the sum of the digits which is given here, 8. Okay, that's it. It's called digital sum, sum of the digits, and again digital sum. You reduce it to one single digit. See, 7 plus 9, 16, 16 plus 10, 26. So, 2 plus 6 is equal to 8. Similarly, 9 plus 11, 20, 20 plus 30, 50. 50, 5 plus 0 is 5. Hence, this has to be, see, 23 plus 4, 27, 27 plus 15, 42, which is nothing but 6. Hence, the answer is 6. Okay, this one, let's x be the positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Okay, how many such values of x are possible? See, look here now. You put for any value of x here, 1, 2, 3, 4, 5, 6, this will get divided again. So, to get 96 divided by x, this number has to be either 1 if I put 96 divides, 2 divides, 3 divides, 4 divides, 5 not divides, 6 divides, and 8 divides 96, 12 divides 96, 16 divides 96, what else, 24 divides 96, 32 divides 96, 48 divides 96, and 96 itself 96. This is just the factors of 96 question. So, how many such factors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay. PQ, RS are distinct single digit positive numbers. Okay, they are single digit and positive numbers like plus 1, plus 2, plus 3. Then what is the greatest value of? See, greatest value means you have to take the largest numbers. Largest numbers, you have 4 numbers. Okay, largest means it has to be 6, 7, 8 and 9. Now we have to find the combination 6, 7, 8 and 9. Now so many such combinations are possible, but to get the maximum or the greatest values, remember always P plus Q has to be equal to R plus S. Then only this becomes a maximum value. Okay, you get the maximum value only when P plus Q is equal to R plus S. So, now how to make this P plus Q is equal to R plus S, which is nothing but what? 7 and 8. Okay, and this is 9 and 6. This is the maximum value you will get. Okay, so this is 15 into 15, which is nothing but 225. Other possibilities also you can get 224, 221 also you will get, but the highest value you can get is 225. A number n is formed by writing 9 for 99 times, then 9 for 99 times, for example 9, 9, 9, 9, 9, such 99 9s. Then the remainder, if n is divided by 13, so this number when divided by 13, look here now, when 9 divided by 13, remainder I am writing, remainder is equal to 9. Okay, when 99 divided by 13, okay, the remainder 8. When 999 divided by 13, the remainder is 11. When 9999 divided by 13, remainder is 2. And when 5 9s is divided by 13, remainder is 3. And when 6 9s are divided by 13, remainder is 0. Okay, this gets divided. Means, okay, means for every 6 9s, it's exactly divisible by 13. If I write one more again 9, the remainder is 9. If I write 2 more 9s, that remainder is 8. If I write 3 9s, then it has to be 11. So, When 99 nines are there, okay, all the 6 nines I can cancel out like this, and because the remainder is 0. 6 nines, 6 nines, 6 nines, 6 nines, if I divide, okay, if I cancel out, so 96 nines will be cancelled out. Only the remaining is last 3 nines. When last 3 nines is divided by 13, okay, remainder would be, okay, here it has to be 11, I guess. Okay, remainder it has to be 11. Okay, cyclicity concept. Next one. Each of a 9-digit number is, see, each of a 9-digit number is 1. Each digit of a 9-digit number is 1. It is multiplied by itself. Then what is the sum of the digits of the resulting number? Now look here. There are, let's say, 2-digit number are there. Both are 1. Okay, if you multiply the same with the number itself, then it is 1 to 1. Similarly, 111 into will be 1, 2, 3 and 2, 1. 1, 2, 3, 4, 1, 2, 3, 4 and 3, 2, 1. See, look here, observe what is happening. When I write 4 here, that's 1, 2, 3, 4, okay, afterwards 1, 2, 3 written. Okay, if it is 3, 1, 2, 3, afterwards 1, 2. Similarly, when I write 1, 2, 3, 4, 5, 6, 7, 8, 9 into 1, 2, 3, 4, 5, 6, 7, 8, 9, I will get 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, and afterwards 8, 7, 6, 5, 4, 3, 2, 1, okay. This has to be the number, and the sum of the digits of that number. See, look here, 9 plus 1 is 10, this is 20, 30, 40, 45, okay, this is 45. Again, if I add this one also 45, since I have added 9 on both sides, this is 50, 90 minus 9, which is nothing but 81. Sum of all digits which appear in all the integers from 10 to 100. It's not the sum of the numbers he is asking, sum of the natural numbers. Okay, it's nothing but the sum of the digits from in these natural numbers 10 to 100. Look here now, I am writing from 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. Okay, here it is sum is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, 6 plus, 7 plus, 8 plus, 10. Okay, see, look here, 1 plus 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, sum is 10, 20, 30, 40, 50, 55. Okay, always it is 55. Okay, isn't it? Now, I am writing again 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 29, let's see. Okay, here the sum is 2, 3, 4, 5, 6, 7, 8, 9 and I will add 11. Okay, now if I subtract, see, 1 is gone and 11 is added, means totally 10 is added. So, totally this is 65, isn't it? Okay, totally this is 65. Again, 1 and 2 gone. Similarly, if I write like this, see, if I take out common 5 here, this will be 11, this will be 13, this will be 15, this will be 17, this will be 19 and so on. Okay, 19, I am writing 21, 23, 25. See, this is 10 to 19 sum, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89 and 90 to 99, which is nothing but 27. Okay, and plus 1 because of 100, isn't it? Okay, now see, 5 if multiplied with even into even, you will get even number. If multiplied with odd, you will get odd number, right? Okay, odd number means 5 when multiplied with even number means 0. 5 when multiplied with odd number means odd 5. This has to be the 0, this has to be 5 you will get. Let's look here. Now, this and this even, okay, sum of these two even, sum of these two even and sum of these two will be even and only one thing is left out, that is nothing but odd. Hence, 5 into this number odd, 5 into odd is nothing but odd. Odd is possibility is 5 only. Okay, 5 only. If you add 1 to it, the number has to be 6. Anything ends with 6, that has to be the number. No need to multiply and see everything. Okay, use smartness, number system. Okay, I am working on the unit digit here, that is it. ABCD is a square. ABCD is a square. 1 point on each of AB and CD. There is 1 point on AB and CD, and 2 distinct points on each of BC. Okay, BC 2 points, and DA. Okay, how many distinct triangles can be drawn using any 3 points as vertex out of these 6 points? Out of these 6 points means 1, 2, 3, 4. No, this is not right. This is not a point here. Okay, 1, 2, 3, 4 and 5, 6. Okay, now many such triangles can be drawn. Out of 6, if you have to choose 3, so 6 C3, which is nothing but 20. Okay, 20 such triangles can be drawn. This is a pretty direct and easy question. Now, a box contains 14 black, 20 blue, 26 green, 28 yellow, 38 red and 54 white balls. Consider the following statement. So, totally 180 balls are there. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175. Okay. Now, okay. The smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color is 167. Okay. This is case of at least. Let us see first this one. At least case, the smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color is 167. Now look here, out of this 180, 14 blacks are there. Let us say I haven't taken any black. So out of 180 minus 14, which is nothing but 166 I have drawn. Okay, 166 times I have drawn, I haven't got anything black. Okay. Now, when I draw next time, 167th time, I will get one black, right? In this 167th time, we have black also, blue also, green also, yellow also, red also, white also, isn't it? And at least one of the color we are having, right? Here, at least one of the color. So, this is the smallest number for at least one of the color. So, hence this is true. Okay. Now, we will go to the first one. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175. One full group, it must be there. Okay, now, coming to this point, the smallest number n such that n balls drawn from the box randomly must contain one full group, at least one color. Okay, group full has to be there. Now, in this 180, we have completely all the colors, all the group, completely we have group here. Okay, completely we are having group. Let us say I have taken out one black, one blue, one green, one yellow, one red and one white. So, totally I have taken out how much? Minus 6, which is nothing but 174. In this 174 balls, whatever I have drawn, okay, we don't have any single group completely considering the colors there. Okay, we don't have one. Now, I am putting one, any one you put. Okay, either you put black or blue, anything. So, this becomes 175. In this, one of the color is completely, we are having the group, right? Hence, this also is true. So, this is both 1 and 2. Both 1 and 2 this is. See that option. Okay, this was a pretty easy one, direct one. 0 is written as CHUR. See, this is plus 3, it's been. The code is plus 3 here. Plus 3, plus 3, plus 3. So, the answer is D here. Okay, you can do this one. Consider the following statement. This is an inequality kind of question. A is older than B. Okay, see, A is older than B. C and D are of the same age. C and D are of the same age. E is the youngest. Okay, E comes somewhere here. E is the youngest. Let's keep this one. F is the younger than D. F is younger than D. So, F comes somewhere here. F is older than A, this has to be. Okay. Now, F is older than A. Now, see, if I have to write this one, F is older than A and A is older than B and E is the youngest. Now, How many statements given above are required to determine the oldest person? See, oldest person. Now, A is older than B. We require anyway this one to say that E is the youngest one and A and B comes here, and F is older than A, so F comes here. So, E is the youngest. E is the youngest means E comes here. If I don't give this statement, E is the youngest, okay. So, E can be anywhere here, okay. E can also be the oldest. F is the older than A, hence all 5 we need. Okay, this one. What is the relation of E to B? Statement 1, A and B are married couple. See, A and B are married couple. D is the father of C. E is D son. A and C are sisters. See, sister. This has to be the male. A and C are sisters. Then D is the father of C. D is the father of C. And E is D's son. D's son is, so these two has to be siblings. Then A and C are sisters. That's it, right? Okay. Now, how is E related to B? Okay, E related to B. See, if I don't have all this information, all 4 statements are sufficient here. This is not sufficient. This is sufficient. We can establish, okay, E to B, brother-in-law, sister's husband. Choose the group, okay. This also, look here, these are all prime numbers, prime numbers, prime numbers. Here also prime number. 1 is not a prime number, 91. Hence, option D, this group. A principal amount becomes P, becomes Q in 1 year when compounded half yearly with R% annual rate of interest if the same principal P becomes Q in, see, this is a half yearly question, okay, compound interest half yearly question. With S% annual rate of interest, then which one of the following is correct? Let's say, see, for example, 10% per annum. If the rate of interest is 10% per annum, if it is a 1 year question, you have to pay only 10%. If it is a half yearly question, then you have to pay 5% half yearly, then again 5%. But here, this is a compound interest. Okay, 5% anyway you are paying in the first half of the year. Okay, second half of the year, this 5%, along with this 5%, on this one also 5% means 0.25%. So, totally 10.25% you have to pay. Okay, remember, we have done these things in a class, half yearly question. 5% plus 5%, okay, totally 10.25% this would be given. See, it was supposed to be 10%, okay, here, but half yearly 10.25% means 10.25%, but still you are getting the same, right? Okay, if the same principal P becomes Q, P is becoming Q everywhere, at R% also, at S% also, but this is half yearly, this is full year. This was supposed to be 10.25%, but this was supposed to be 10%, okay, but still you are getting Q means this has to be less, right? This was supposed to be 10.25%, but you are getting the same amount means the R has to be less than S. Okay, R has to be less than S. It was supposed to be more, but you are getting less means R has to be less. Okay. See, this is a conceptual question. Okay, we have to develop a concept here, but okay, with lot of trial and error. This is a lengthy procedure to explain here. Hence, I am skipping the explanation part. I am giving only the answer. The answer is 6 here. Okay, the answer is 6 here. I will come with the explanation for this kind of questions. Okay, once again. Here also, see, I have an ambiguity here. I don't know the exact answer for this one. The number of possible values P is 5 and Q is also 5 I am getting, but I am not sure about this one. Okay, hence I am not giving the answer or explanation for this part. It can be one only or else both. Okay, one only or both. I have ambiguity here. Okay, hence I am skipping this question also. Now, this one. What is the sum of all 4-digit numbers less than 2000 formed? Less than 2000 means it has to start from 1 only, 1, 2, 3, 4. Okay, these are the digits. 1, 2, 3, 4 means 1, 2, 3, 4. 1 remains in this position only. 2, 3, 4 will be changing. How many different ways? 2, 3, 4, 2, 4, 3 and 3, 2, 4, 3, 4, 2, 4, 2, 3, 4, 3, 2. Okay, everywhere 1 is common here. Now, sum all this, that's it. Okay, 2 times of 4, 2 times of 3, 2 times of 2. We have done these things in class also. Okay, this is 8, 10, 15, 18. This one is 18, again plus 1. This has to be 9. What do we have? 9 and 8. This is the only option. Okay, no need to do everything here, 9 and 18. Okay, see every column you will be having, you will be getting 18, 18, 18 till here. Okay, 18 plus 1, 19 here, again 18 plus 1, 19 and this one. Okay, very similar question we have done in class also. What is the number of selection of 10 consecutive things out of 12 things in a circle taken in a clockwise direction? See here, remember 12 things he has read, not the 12 numbers. Okay, 12 things, but still let's, for our reference, name that things as 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you have to pick 10 consecutive in a clockwise direction. Consecutive means one after the other. 1, after this one 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 to 10 you can pick. Then afterwards starting from 2 to 11 you can pick. See, these are things, again I am saying, these are not the numbers here. Okay, they are things placed here. Okay, we have named that things as numbers here. Then again 3 to 12, 4 to 1, and this continues, right? This continues till where? Till 12. Okay, 12 to 10 you can pick. 12 to 9 I guess, right? Yeah, 12 to 9. Again if you go to the 1, this is a repetition case, right? Okay, this is a repetition case. If you go in that way, that's a n number of possible cases, but here you have to restrict till. So 1, 2, 3, 4 till 12 you can take. So 12 would be the answer. Pretty simple question. Okay, if you don't overthink, you can get the answer here. If today is Sunday, then which day is exactly 10 par 10 days? Okay, cyclicity. See, cyclicity 10 divided by 7, remainder is 3. Okay, similarly 10 square, that is 100. 10 square divided by 7. Okay, again 3 into 3, 9. So that is 2. Okay, similarly, okay, 2 into 10 is 20. 20 by 1 is minus 1, that is 6. Okay, 10 power 4 by 7. 6 into 10, 60. 60 by 7, 56. Remainder is 4. Okay, then again 10 power 5 divided by 7. 7 into 4 into 10, that is 5 in this case. Okay, 10 power 6 by 7, that is 50. Okay, 50 by 7, remainder is 1. Once you get 1, okay, the remainders will repeat again and again. Say again 3, 2, 6, 4, 5, 1. 3, 2, 6, 4, 5, 1. This is cyclicity. So cyclicity to appear again and again, you have to go 6 times. Cyclicity is 6 here. Means when you divide this by 6, remainder is 4. Okay, remainder is 4 means what is the 4? 10 divided by, okay, 1, 2, 3, 4, which is nothing but 4. Okay, Sunday plus 4 days, which is nothing but Thursday. There are 3 traffic signals. Each signal changes color from green to red and then from red to green. Okay, green to red, red to green, and this continues. The first signal takes 25 seconds. To second signal takes 39 seconds. Okay, you know that this is a pretty LCM question, direct question. Okay, you take the LCM 25, 39 and 60. Okay, so LCM is equal to 65 into 60, which is nothing but 65 minutes. So every 65 minutes it changes. Okay, every 65 minutes the signal changes. Now it has changed 2 p.m. At 2 p.m. they together turn green. Okay, all the signals turn green. At what time will they change to the green next? See, once it changes green, the signal will be changed in the next 65 minutes. In 65 minutes, green becomes red. Again to red become green, it takes another 65. 65 means totally 130 minutes. Okay, totally 130 minutes means 2 hours 10 minutes. 2 hours 10 minutes from 2 o'clock, which is nothing but 4 hours 10 minutes. Okay, do not get confused here. This is 65 into 2. 40 children are standing in a circle and one of them has a ring. The ring is passed clockwise. Child 1 passes on to child 2, child 2 to the child 3, child 4 to child 7 and so on. Means first child passes to the second child, second to fourth child, then 7th, then it has to be 11, then it has to be 15. See the difference here is 1, here it is 2, here it is 3, here it is 4, here it is 5, here it has to be 6, that is, here it has to be 7, that is 29, here it has to be 8, okay, 37 it has to be, isn't it? Okay, once you get 37, if you add 9, this becomes 46. but only 40 children are there. Okay, 40 children are there. See, this is nothing but the difference, okay, has to be same. The difference has to be same. See, in this case, this is a simple classical example of n into n plus 1 by 2, which is equal to 40, where n into n plus 1 is equal to 80. But in no combination of n for an integer, you will get 80. Okay, for no value of n, you will get 80. But let's see for 80x. Okay, if you put 1, 2, 3, 4 for the value of x, okay, then at some point you will get. See, if I put 1 here, 80, it doesn't match us, so no possible values. 2, 160 also no possible values. For 3 you will get. Okay, means you will get 240. You will get 240. How? This is 16, this is 15. Okay, so n value is nothing but what? It has to be 15 into 16, where n value is equal to 15. Okay, these kind of questions we are done in a different way, but here asking question is in different example. What is the middle term? Okay, see, this is one of the again toughest one. Okay, it takes, let's see, toughness depends on the timings here. It takes a lot of time and effort here. Okay, I'll give just the answer here. Okay, let's see, I can build a concept for this one. Here it is h here. Okay, here it is h. Answer is, I'm skipping this also for the explanation part. This is p square. This is g square. Is p greater than q? P into g is greater than 0. Greater than 0? Not necessarily always, because see, he has not given anything positive integer, even, odd, nothing. Okay, positive or negative, anything you can take. If you take minus 1, this is, okay, p is greater than q. This is plus 2. So, this is minus 2, it becomes, is it greater than 0? No, in this case. Similarly, p square, in this case, minus 1 whole square. Okay, this is minus 2 whole square you can take. Okay, minus 2 also you can take. So, this is 1, this is 4. So, 1 is less, hence both statements are wrong. Okay, which one the question can be answered? The question cannot be answered even using both the statements here. Option D, where P, Q and R are, P, Q and R are integers. Statement 1, P minus Q is positive. P minus Q is positive means P has to be greater than Q, isn't it? Then only it will get positive. Q minus R is negative. P minus R is negative. So, P has to be less than R. So, R has to be greater. So, R greater than P greater than Q. Now, which one of the following is correct with respect to the above question? Okay. The question can be answered by using, what is the question? P plus G minus R greater than P minus Q plus R. So, I have checked all these possible cases here. In all the cases, yes. Okay. We need both statements to answer this question. Okay. Hence, the answer is, the question can be answered by using either statement alone. No. Using one of the statement alone. No. The question says both the statements together, but cannot be answered. Yes. Option C. Okay. I have checked some of the values. Okay. Taking. Hence, the answer is C. Now, this question. See, this is, we can do the Venn diagram here. Okay. This is tea. This is coffee. This has to be total 75, this has to be 60, both has to be 50. So, this is 60 and this is 45. So, the total coffee plus tea is equal to 120, and we do not have any idea about the milk. So, how many people attended the party? Okay, the one people who attended the party, they are drinking one thing or the other, at least one drink they are drinking. Now, 50 people took milk, 50 people took milk. Okay, let us say this is the statement, data given. Number of people who attended the party is 5 times the number of people who took milk only. See, we don't have any information about milk only. How can you deduce? There is no way to deduce the milk only. Hence, if you don't know this part of the information, okay, how many people attended the party? Okay, we cannot say. None of the data is supporting to get me to the answer how many people attended the party. See, this is the number of people who are drinking tea and coffee in the party, 120 people. Okay, we don't have any information about only milk. Okay, hence unsolvable. Consider a 3-digit number. The sum of the digits of the number is equal to the product of the digits. See, sum of the digits equal to the product only possible for 1, 2, 3. Okay, or 2, 3, 1 or 3, 2, 1. Okay, these kind of numbers. Okay, these kind of numbers which are formed using the combination of 1, 2, 3. Now, the sum of the digits of the number is equal to the product of the digit. Yes. Then this number is divisible by sum of the digits of the number. Now, 123 if you take, this is not divisible by 6. But if you take 312, this is divisible by 6. Okay, so the number is what? 312, not 123. Okay, 312 is also possible. So, which one of the following is correct in respect of above question and statement? Both are correct. The question can be answered using both the statements together, but cannot be answered using only one. Yes, because using only one, this one, you cannot answer the number is divisible by sum of the digits of the number. Many such possibilities are there. Sum of the digits of the number is equal to the product of the digits, then 1, 2, 3, but the number is 312. We need both of these statements. 5 children age group A less than B less than C less than D less than E. Okay, successive age difference of 2 years. Okay, they are in arithmetic progression. Difference between A, B, BC, CD and DE respectively is 2 years. And what is the age of the youngest child? Youngest child. Okay. See, whenever the series is in AP, okay, A, B, C, D, E, this is the average. And the average of the is given as 8 years. Or else the difference between these two is 2, 2, 2 or 2. So the difference between these two is 8 years. Okay, average is equal to 8, middle values is equal to 8. What is asked? What is the age of the youngest child? The age of the eldest is 3 times the youngest. So this is 3x, this is x. So the difference between these two, 2x is equal to 8. So x is equal to 4. Okay, if this is 4, you can add 8. So that has to be 12. So any one of the statement you can answer. The question can be answered by using one of the statement alone, but cannot be answered using the other statement alone. The question can be answered by using either statements alone. Either statement alone is sufficient to answer this one. Average question. In an examination, the maximum marks for each of the 4 papers, namely P, Q, R and S are 100. Marks scored by the students are in the integers, and a student can score 99 percentile. Okay, in the different ways. What is the value of n? N different ways. Now he has to score 99% in 4 subjects, P, Q, R, S. Okay, maximum score is 100 marks. So maximum possibility, see 100 he can score, here 98 he can score, 98 he can score. Okay, now see if I put the combination, this 100 can go here, 98 can come here, this 100 can go here, 98 can come here, 100 can go here, 98 in this way. But here, how many different ways? 4 factorial divided by repetition is there, 2 factorial into 2 factorial ways. This is one possibility. Then or else 100, 90, 1, 2, 3, 96 we can say. So this is 4 factorial by 3 factorial to avoid the repetition here, right? Okay. Similarly, 99, 99, 99, 99. This is also possible. Okay, this is only one way. Any way you change, that's 99 only. Then afterwards, what else? 100, 99, okay, and 97 also. This is also possible. This is 4 factorial by 2 factorial. So this is 4 factorial by 2 factorial. This is 6 ways. This is 8 ways. And this is 1 way. And this is 12 ways. Okay, one more possibility. 100, 99, 100 and 90, 100, 99 and 98 also possible, right? I haven't written this one. Okay, now see, this one is again 4 factorial by, this is 2 factorial. This is again totally, this one 4 factorial by 3 factorial. This is only 4 times, isn't it? This is 4 times. 4 into 3 into 2 by 3 into 2. So 4. This is 1. 4 factorial by 2. 2 get cancels. 3, 12. This is, okay, 24 by 4. That is 6. And this is 12. 24, 30, 34, 35. Now correct. Okay. This one is correct. 35. possible ways. See, look here, I'll explain once again. PQRS 100, 100, 98, 98, this is possibility. So 4 factorial, 4 position. To avoid 200s, repetition 2 factorial. To avoid 98 2s, 2 factorial. This is 3 times of 100, hence 3 factorial. This is 4 times of 9. Anything 4 factorial by 4 factorial is equal to 1. This is 2 factorial, you have to avoid. Okay, that's why 4 factorial by 2 factorial 12. This is 100. Okay, 99, 99, 2 factorial, I am dividing 12, 12. Hence, this is 35. That's correct. A flag has been designed with 4 horizontal stripes. See, 4 horizontal stripes with red, green, yellow. Okay, red, green, yellow. What is the number of different ways in which this can be done so that no adjacent stripes have same color? Means see, red, green, yellow. See, this is one possibility. Here you can fill anything other than red, yellow. Means see, you have 1, 2, 3, 4 positions. 1, 2, 3, 4 positions. Let's say for these 3 positions, you have 3 colors. So how many different ways you can fill this one? 3 factorial ways. And for this one, okay, you can fill either of the color, right? Okay, because see, this can change here. This can also come here. So 3C1 ways you can fill here. Not necessarily yellow only you can. See, if you put yellow, yellow can be put here, red can be put here. Okay, so in this way, 3 factorial into 3. Okay, this is one of the way. So totally this is 3 factorial, 6 into 3. 18. Okay, and also in this way also you can red, green, red, 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 green, red, green. Okay, in this way also you can write red, green, red, green. 2 times of red, 2 times of green. Here 2 times of only one color, 2 times of 2 colors we have used. So red and green, okay, 2 types. Because green and red also you can write. Using red and green 2 times. Similarly, green and yellow you can do the same 2 times. Okay, 2 times. Yellow and red also you can do 2 times like this only. Okay, paint like this. So 2 plus 2 plus 2, that is 6. Totally 24 such. Okay, for this position any color. Do not think that is yellow means repetition. Yellow you can put here, red you can put here. Okay, in that case 3 factorial into 3C1. Okay, a rectangular floor measuring 4 meters in length and 2.2 meters in breadth. See, 400 meters, 400 centimeters and 220 centimeters. Has to be laid such that the tiles do not overlap. A tile can be placed in any orientation so long as edges are parallel. Okay, edges are parallel. What is the maximum number of tiles can be accommodated on the floor? And the size of the tiles is 140 by 60 centimeter tile. Okay. Now look here, how I will place these things. Here 60, 60, 2 tiles like this. Okay, so the length will be like this, isn't it? 140 here, 140 consumed totally. Okay, in this remaining area, I cannot place any of the tiles, isn't it? Because if I place here, this is again I need 140 more. Here already 140 occupied out of 220. So the remaining here is only 80. So you cannot place any tiles here. So 2 tiles placed. Now I'll place in this way. So totally how much is left out here? Out of 400, 120 gone means, see this is 280. Okay, 280. Now I can place 140, 142 tiles, right? Like this. So it will consume here 60. Okay, again if I, this one 140. Again I will consume 60 here. So totally 120 gone. Okay, 120 gone. Now again I can here 60. So totally 180 gone. 180 out of, so remaining is 40. Here I cannot do anything. So how many tiles I placed? 1, 2, 3, 4, 5, 6, 7, 8. Okay. No overlapping and everything is oriented to the edges parallelly. Now, there are 5% PQRST, one of whom, see, this is also an ambiguous question. I don't understand this question, whether it's a task has to be given to each one of them or else one task. Okay, see, this is one ambiguous one. I'll skip this part, skip this particular question. There are large number of silver coins weighing 2 grams, 5 grams, 10 grams, 25. Okay, consider the following statement. To buy 78 grams of coins, one must buy at least 7 coins. Okay, 78 grams of coins, one must buy at least 7 coins. At least 7 coins, yes, you can say at least 7 coins you can say. See, 50 grams, 25 grams, 10 grams and 2 grams. Now 50 grams, you can take one. 10 grams, you can take 2. Okay, now correctly printed. 2 grams, 4. So totally this becomes 7, isn't it? 7 coins. Okay, anything you can do. You reduce the 10 grams, you can increase the 2 grams. Okay, then the number of coins will increase. Okay, this one, at least 7 coins, yes, maybe. To buy 78 grams of coins, I am buying 78 grams of coins now. Okay, 78 grams of coins now. Must buy at least 7 coins. Now, to weigh 78 grams using these coins, after taking this 78 grams of coins, now I am weighing a product like banana. Okay, let's say banana, I am weighing 78 grams. Okay, a customer comes to me and I have to give him 78 grams of banana using these only weights. Okay, or else less than these 7 coins. Can I do that? Let's see. See, look here now. I am weighing this one now. Let's say this is the weighing scale. Okay, weighing scale. Here I am putting 50 grams, 50 grams, 2 coins. Okay, 2 coins. So totally this become 100 grams. Here I am putting 10 grams, 10 grams and 2 grams, totally 3 coins, and this becomes 22 grams. Have you seen these things? Okay, if you are buying 900 grams, let's say, he'll put 1 kg here and he'll put 900 grams of banana here. If you don't have 900 grams, he'll put 100 grams on this banana and he'll make equal. Okay, this is how he'll make equal. That's what I'm doing here. 100 grams here, 50-50 means 100 grams. I'm putting 2 coins here. Okay, so 3 coins here, which is of 22 grams, which becomes, now I'm putting the banana here, which is of 78 grams. So here, this will be at the middle only, right? This becomes middle. Now, using this technique, I weighed 78 grams, isn't it? To weigh 78 grams, he is asking. This is to buy, this is to weigh using them. Now, to weigh this 78 grams, how many coins have you used? 2 coins here, 3 coins here, only 5 coins. Less than 7 coins? Yes, possible. Less than 7 coins? Yes, possible. Both 1 and 2 are possible in this case. See, UPSC mentions read carefully means read carefully. Okay, literally, carefully you read. Okay, we'll move on to the next one. This is a pretty simple question, inequality. Okay, we have done this in class itself. A plus B means A is neither smaller nor equal. Neither smaller nor equal means it has to be greater. Okay, this means A greater than B. Then A minus B means A is not greater than B. Not greater than means it has to be A smaller than B. Minus means. Then A into B means not smaller than B. Not smaller. Okay, not greater means it has to be smaller or else equal. In this case, is not smaller means it has to be greater than or equal to. Division, this is plus, so this is minus, so this is into, this is division. Neither greater nor equal. Neither greater nor equal means less than B. This is neither smaller nor greater than means plus means equals to B. Now, okay, P into Q, P minus T, T division R plus or minus, yes. Okay, so this is plus or minus, isn't it? This is also plus or minus here. Let's see. Okay, into means what? Into is A greater than or equal to B. P minus T, minus is. Then T division. Then this is R is equal to S. Okay, now let's conclude. Let's see this one Q, which is equal to Q is equal to T. Okay, let's say he is asking us to travel from Q to T. Okay, this is a technique. I have done it in the class itself. Q to T. Okay, what I have done here. Okay, this is P, this is Q, this is P, this is T, this is T, and this is R, and this is RS. Okay, confused with the variables here. Okay, let's see. Q to T. Can I go from Q to T? See, Q to anywhere you cannot travel because this is a closed gate. Okay, this side of the gates are closed one. Okay, this side of the gates are open one. For example, you can travel from R to T, but you cannot travel from T to R. Hence, Q cannot be gone to anywhere. Hence, no. Then, S plus Q. S plus Q. What is plus here? Plus is S is equal to Q. Plus, okay, this is plus or minus, right? Okay, this is S. S has to be greater than Q. Let's say S to Q can be traveled. S to R I can travel, R to T I can travel, afterwards T to P I can travel, P to Q also you can travel, P to S, okay, isn't it? So, you can travel here, P to Q, S to Q, okay, S to R, R to T, T to P, P to Q, and one of the symbol has to be at least this one. Yes, we have at least this one symbol here. Yes, this follows. Okay, conclusion 2 follows. Only conclusion 2 follows. Okay, remember inequality we have done in the class itself. Very similar approach. Can solve this one. Easy, simple question. Okay, next one. What is the remainder when 2 power 192 is this one? Okay, 2 power 192. So, can I write this as 4 power 81? Okay, 4 power 81 when divided by 6. See, when 4 divided by 6, remainder is equal to 4 only. When 4 square divided by 6, remainder is 4 only. 4 power 3 divided by 6, remainder is 4 only. 4 power n divided by 6, remainder is 4 only. So, it is 4 only here. Okay, consider the sequence. Okay, we have done this in the class itself, the previous one also. See, count the characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. Okay, you can divide this into 5, 5. Yes. Okay, if you check all the possibilities here, CD. Okay, this one works. DD, CA. I guess, see, this has been repeated here. Okay, the sequence. This is the answer. The sequence has been typed wrongly here. Okay, refer your question paper. Divide this into 5 parts. Okay, you will get DDCA there. DDCA. It's been wrongly typed there. ABC dash dash ABC dash DABBCD. This is a single one here. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So totally 5, 5. You can divide 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So if you put D, C, A here, look here, B, B, C, D, D, A, B, C, C, D, A, B, B, C. Okay, you can look at the pattern here. So that's what taught in the class also. Okay, divide when you have 20, 4 into 5 or 5 into 4 you divide. Now, AB and CD are 2-digit numbers. Multiplying AB with CD, result is a 3-digit number, that is DEF. Adding DEF to another 3-digit number, GHI, the result is 975. Further, ABCD distinct digits. Okay, they are distinct digits. If E is equal to 0, F is equal to 8. Okay, then what is the possible values of A plus B plus C? Now look here, if F is equal to 8 here, okay, to get 5 here, okay, it's not getting 5 here, it has to be 15. So 15 means this has to be 7, isn't it? So we got the value of I is equal to 7. Okay, so 15, 1 carry here. Then E has to be 0 here according to the question itself. So this is H has to be 6, then only this becomes 7. So H value is equal to 6 here. Okay, 7. Here D and G sum. Okay, D plus G is equal to 9. Okay, D and G has to be 9 means it can't be 6 here because H value is 6. So this has to be 5 and 4 or 4 and 5. This is the only possibility because 7 and 2 is not possible, 8 and 1 is not possible because F is 8, I is 7, H is 6. So 5 and 4 or 4 and 5, this has to be. Okay, so 0 is gone, 1 is there, 2 is there, 3 is there, 4, 5, 6, 7, 8, 9 gone. So 1, 2, 3 is there and only 3 variables A, B, C. Okay, you put in any combination 1 plus 2 plus 3. So the sum is excuse me, sum is 6. Those are the remaining digits. Okay, pretty simple question. Consider the following statement with respect to 5 candidates. Now, P, Q, R, S, T, 2 statements are true and 1 statement is false. P and Q got selected for the job. One of P and Q was selected for the job. Okay. Statement, false statement. At least one of R and S was selected for the job. At most 2 of R and S were selected for the job. Now, which of the following conclusion can be drawn? At least 4 were selected for the job. See, P and Q are selected for the job and this is false. Okay, anything you can take. True statement is at most 2 of R and S. See, at most means it can be RT, it can be ST, it can be SR, many possibilities. So, at least 4, no, here 2. Here, at most 2 means there are other combinations as well as individually also they can R or S or T. Hence, 3 also is possibility. At least 4, no, it's not possible. S was selected for the job. See, yes, P and Q got selected anyway here. Here there is a possibility that S will get selected because at most 2 means 1 also get selected. 2 also, in that 2, Rn might be selected. Okay, so S, hence neither 1 nor 2. Yes, not getting selected here. Okay, that's not sure conclusion. Now, P, Q, R, S, T, 5 statements such that P is true. If P is true, both Q and S are true. See, P will be true only when Q and S both are true. If Q is false or else S is false or both are false, in that case P is not true. If R and S are true, then T is false. See, T to get false, these 2 has to be true. Okay, if this any one of these true or else both are true, then this changes. If T is true, then at least one of P and R must be false. Yes, of course, if this is true, at least, see, at least means R and P and R. No, P and S, okay, so this is not true. If Q is true, then P is true. If Q is true, then P is true. No, it depends on S also, right? This is not. Okay, let's read the first one again. If T is true, at least one of the P and R must be false. P and R must be false. No, okay, this is neither 1 nor 2. Okay, this is neither 1 nor 2. Okay, this one, a cuboid of dimension 7 cm, 5 cm, 3 cm, painted red, green and blue, and opposite faces 7, okay, 7 into 5, 5 into 3, 7 into 3 respectively, blue, GR, RGB. Okay, separated. Now look here, I'll draw this one. This is a cuboid required and we'll make the partition 7 into 5 first. Okay, 5 will do this one. 7. This is 7. Again, this is 1, 2, 3, 4, 5. 5 into 3 we require, right? 1, 2, 3. Okay, this is 7 into 3. This is 7 into 5. This is 5 into 3. Okay, 7 into 3. 7 into 3 is blue. And 5 into 3 is green. This is red, right? Okay, this is the one. Now, there are exactly 15 smaller cubes with no paint on any face. 15, is it? See, now these are painted. Now, if I remove these paints, remove the upper part, okay, exterior part, very similar to the earlier question, okay, very 2 similar questions were asked here. So, only thing which will be left out here is inside this one, like this much. Because this will be removed, above is removed, below is removed. So, how many are there? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So, totally 15 smaller cubes with, see, only this much will be removed. Okay, if I am removing this one, only this strip will be there. okay, which is below this one, which is looking like this. So totally 15, yes, of course. There are exactly 6 smaller cubes with exactly 2 faces, one painted with blue, exactly 6 faces, one is painted blue, one is painted blue and another one is green. One is blue and another green. Okay, where is blue and green? Okay, this is blue and this is green. Let's see how many are there, blue and green. See, this is blue, green, 1, exactly, okay, 1, 2 we have here, okay, exactly means only, see, there are exactly 6 smaller cubes with exactly 2 faces, exactly 2 faces he has used, exactly 2 faces means none of the other faces has to be colored here. Now, if I take this one, this is the colored red here in this face, hence I cannot take this one, this I can take because this is a red and this is blue, this is red, this is blue. Okay, here similarly red, blue, similarly here also you'll get. So totally 4 you'll get, you won't get 6, it is 4, hence this is wrong. So 1 only. Now I have made this one, okay, in comprehensibilities. Okay, this is the word letters and you have to take and you arrange that in a reverse order. Okay, I am arranging this one in a reverse order. B, C, triple E we have, H, incomprehensibilities. Okay. How many we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. Five I's we have and an L, 1 M, 2 N's and an O, P, R, double S and T. Okay, see here we have I, here we have I. So this is 2, answer is 2 I's. Okay, none of this will remain in the same position. Okay, next one. Okay, so we had some 2 to 3 ambiguous one. Okay, I have to develop the concepts for that one. As of now, this is the most appropriate key answers. Okay, so you can rely on these key answers. Okay, check, verify, and good luck, guys. Okay, good luck.